All right, so in today's lesson, we're going to be talking about composite functions. And that's where it's kind of like we're sticking one function inside of another one. We're going to talk about when you would use something like this and how it's done. And we're going to do it with this example. I don't know if you guys like shopping at Kohl's or not, but if you do, you're like my wife. She likes to shop at Kohl's. Sometimes we have a 30% coupon. So there's a 30% off sale. Sometimes she gets a coupon like Kohl's Cash, and you get $10 off of something. And so let's first write a function that represents 30% off. If you get 30% off of something, that means you pay 70% of whatever the price is. So if X is the price of any item, then a function that represents a 30% off is actually going to be 0.70 times X. Which means a $100 item is going to be $70 with the coupon, because you would actually pay $70 of that $100 item. If you just went in with the Kohl's Cash or a $10 discount coupon, then you would have if the X was the price of the original item, then you would just take the price of the original item and subtract 10 from that. And so if we had a $100 item, you could stick in $100 for X, and you would end up paying $90. So that's if we had both of those happening individually. But assume now that we want both of those things to happen. We have the 30% off sale, but we also have the $10 off. Does it matter which one we put in first? Would it make a difference if we took the 30% off and then took 10% off of that? Or if we took 10% off or $10 off and then took 30% off of that? So let's just try this first. Let's assume that we're going to do the sale part first. And we're going to start with a $100 item. With the sale first, if I stuck $100 in for this X, we would multiply $100 times 0.70, and it would be $70. Well, then what we would want to do is we'd have that $70 and we would stick it in for the other function, which is the g of x function. We'd stick that in for x minus 10, and we would have 70 minus 10, and the price would end up being $60. So let's talk about what would happen if we did it in the other order. Let's say that we came in, we bought a $100 item, and we gave them the $10 coupon first. We would stick 100 in for this X here, and 100 minus 10 would be $90. Then we would take that $90 and we would go ask for 30% off of that. And so we would stick 90 in for the other X and multiply it times 0.70. And 0.70 times 90 is $63. And so you can imagine how that's not a lot of savings, but if you buy a lot of items, more than $100 worth, it could be a substantial amount of money. Even $3 is, I've seen people argue and get a manager over even for $3. To try to figure out which one should go first. Well, mathematically, we will describe both of these in different ways. As a composite function, what we're doing is we're sticking one function inside of another one. And so with the first scenario, with the sale first, because that's the f of x, we would take the x and apply the f of x function first, which means we took the x function and we stuck it into the f of x function first, and we got that answer. Then we took that entire answer and stuck it into the g of x function. Review of what we did is we had a $100 item. We stuck it into the f of x function and got $70. Then we took the $70 and we stuck it into the g of x function and got $60. And so that can be described as g of f of x, which is what I have here. But it could also be written as g of f of x, said the same way, just denoted in a different way, which is what I have over on the right hand side. Both of these we would take the x and stick it into the f of x first, and then once we got that number we would stick that number into the g of x function. And so we could also write a single function that represents both. Like for example, if I took the x and I stuck it into the f of x function, well, I would get 0.70x. Then I would take 0.70x, that whole thing, and stick that in for the x in the g of x function, and I would have, instead of x minus 10, 0.70x minus 10. And so we could say that g of f of x is 0.70x minus 10. That would give us one function that does the same thing as both of these functions back to back. In other words, if we started with a $100 item, we would multiply it times 0.70 and get 70, then subtract 10, and we would get the same number that we have here, which is $60. Now, the other order would simply look like this. Here we have the x. We would stick it into the g of x function first, just like we did here. We took a $100 item, we stuck it into the x in the g of x function and got 100 minus 10, which is 90. Then we took that entire number and stuck it into the f of x function, which once we got 90, we stuck it in the f of x function here, and 0.70 times 90, that's what gave us the $63. So we call that f of g of x, which we could denote like this, or we could write it like this, f of g of x. Looks like fog of x, but that's a small, it's not a zero, it's not an O, it's just a small circle that represents the of. And so if I were to write this as a single function, I would start with the g of x function, which is x minus 10, and I would take that entire thing and stick it into the x in the f of x function, which is going to be 0.70 times x. Now we could simplify this. We could get rid of the parentheses. We can distribute the 0.70 and write it as 0.70x, and then we could take 0.70 times 10, which is going to be minus 7. And if I stuck 100 into this function, I would get the same thing that I got here, which is using those two functions back to back, which is the $63. 0.70 times 100 is 70, and 70 minus 7 would give us the 63. So what we're going to be looking to do is to find a function first that represents, here in number 1, f of g of x. So you could think about this as the same thing as f of g of x. Some people like that notation a lot better because you can see that you're sticking the g of x inside the f of x function, but we can write this both ways. So I'm going to stick the g of x, which is 5x, into the f of x function whenever I see an x. So the f of x function is x squared plus 2, but because I'm sticking the 5x in where the x squared is, it's actually going to be 5x squared plus 2. And all I did is I took this 5 of x and I stuck it in for the x in the f of x function. Now I can simplify this. 5x squared we could write as 25x squared plus 2. And that's what f of g of x is. If I want to do the other one with them switched around, g of f of x, I can also write this as g of f of x. Really means the same thing. What I'm going to do is take the f of x function, which is the x squared plus 2, and I'm going to stick that into the g of x function whenever I see an x. So it's going to look like this. Instead of 5x, we're going to have 5 times x squared plus 2. And I could simplify that by distributing the 5. I would have 5x squared, and then 5 times 2 is 10. And so that's what those two functions look like, and they are different and we can recognize that here when we try to find a specific number. Let's suppose that I want to find f of g of 5. And so there's two ways that I can do this. I can go to the original functions and stick the 5 into the g of x function first. If I did that and I stuck 5 into the g of x function, I would have 5 times 5, which is 25. And then I would take that 25 and stick it into the f of x function. And if I did that, 25 squared, I'm doing it up here, 25 squared is 625, plus 2 is 627. Now I could get that same thing, and hopefully if I did everything right, I would get the same thing if I plugged the 5 into the function that I created that represents the same thing as putting the g of x function into the f of x function. What I could do is I could take the 5 and stick it in for this x. And so 5 squared is 25. 25 times 25 is 625, plus 2 does give me 627. Now, if I switch it around and I look over here at g of f of 5, and again, there's two ways I can do this. I can simply just take the 5 and stick it into the f of x function first. If I did that, I'm up here, and I have 5 in for the x, which is going to give me 5 squared, which is 25, plus 2, which is 27. But then I would take the 27 and I would stick the 27 into the g of x function, and so I would have 5 times 27, and let's see, 5 times 25 would be 125, so this is going to be 135. Now, if I did that right, I should get the same thing if I were to stick the 5 into my function, which is right here, that represents the g of f of x function. This function should do the same thing as the combination of the other two functions. And so what I'm going to do is plug 5 into this function. 5 squared is 25, and 25 times 5 is 125. And then when I add 10, 125 plus 10 is 135. And so you can see what we're doing is we're developing functions that take the place of several functions done back to back. And that is what a composite function does. And that's what we're going to be working on our homework for tonight. And we'll go over questions that you have tomorrow.